Imagine a world with little or no concrete. Would that even be possible? After all, concrete is everywhere, on our roads, our driveways, in our homes, bridges and buildings. For the past 200 years, it's been the very foundation of much of our planet. But the production of cement, which when mixed with water forms the binding agent in concrete, is also one of the biggest contributors to greenhouse gas emissions. In fact, about 5% of the planet's greenhouse gas emissions comes from concrete. An even larger source of carbon dioxide emissions is flue gas emitted from smokestacks at power plants around the world. Carbon emissions from those plants are the largest source of harmful global greenhouse gas in the world. A team of interdisciplinary researchers at UCLA had been working on a unique solution that may help eliminate these sources of greenhouse gases. Their plan would be to create a closed-loop process, capturing carbon from power plant smokestacks and using it to create a new building material, CO2-NCRETE, that would be fabricated using 3D printers. That's upcycling. What this technology does is take something that we have viewed as a nuisance, carbon dioxide that's emitted from smokestacks, and turn it into something valuable, said J.R. DeShazo, professor of public policy at the UCLA Luskin School of Public Affairs and director of the UCLA Luskin Center for Innovation. The researchers are excited about the possibility of reducing greenhouse gas in the U.S., especially in regions where coal-fired power plants are abundant. But even more so is the promise to reduce the emissions in China and India, DeShazo said. China is currently the largest greenhouse gas producer in the world, and India will soon be number 2, surpassing us. Thus far, the new construction material has been produced only at a lab scale, using 3D printers to shape it into tiny cones. We have proof of concept that we can do this, DeShazo said. But we need to begin the process of increasing the volume of material and then think about how to pilot it commercially. It's one thing to prove these technologies in the laboratory. It's another to take them out into the field and see how they work under real-world conditions.